Hi, my name is Kamilla and I'm a PhD student at the Department of Veterinary Clinical and Animal Sciences. The work that I want to present for you today on this poster is a study of suitable reference genes for normalization of genes of interest in canine soft tissue sarcomas using real-time quantitative polymerase chain reaction, RT-qPCR. RT-qPCR is a very sensitive and specific method for measuring gene expression. When using RT-qPCR, it is important to normalize your data to some overall stably expressed reference genes. Often more than one reference gene is necessary for normalization. Burstyn et al. Published guidelines for minimal information for publication of real-time quantitative PCR experiments, the so-called MICE guidelines, in 2009. However, there is very limited information on validation of canine reference genes. Therefore, the objective of our study was to identify the suitable number of reference genes for normalization of genes of interest in canine soft tissue sarcomas using RT-qPCR according to the MICE guidelines. Based on the literature, we selected 17 different reference genes, just to name a few: GAPDH, beta-actin, phosphomonomutase 1, and ribosomal protein L8. For each of these potential reference genes, we designed 3 primer pairs using Beacom Designer and tested these primer pairs to find out which one performed the best. The best primer pair was selected based on the amplification plot, as seen here at the top of figure 1, and the dissociation curve, which should only show one melting product to show specificity, as seen here at the bottom of figure 1. For our study, we used archival biopsy material from 6 different dogs with soft tissue sarcomas, and the RNA was extracted using RNA Sol-RT and followed by reverse transcription into cDNA. And finally, we used qPCR with cyprogreen. To calculate the suitable number of reference genes, we used the GNORM algorithm in the Cubase Plus software. This software, designed by Hellemans et al., calculates a pairwise variation factor to assess the variation in expression of 2 candidate reference genes. These variation factors are plotted in a graph like this one depicted in figure 2, and here there is a green line, and as soon as the variation factor drops below this green line, there is limited benefit of including another reference gene in the normalization. Therefore, to conclude, we can see from figure 2 that in this study of canine reference genes, it was necessary only to use 2 reference genes for normalization of the genes of interest. However, it is important to remember that the number of suitable reference genes and the final choice of reference genes is to be tested and evaluated in each tissue and experimental setup under investigation, and that this test of the reference genes should be published according to the MICE guidelines. Thank you for your attention, and feel free to contact me if you have any questions regarding this study.